So how we explain interference, or what is the meaning of interference or superposition of the wave? So when two waves meet, so any point whenever the two waves meet, the total displacement at any point is equal to sum of the displacement of individual wave. What does it mean? Like example, two waves are there, one wave is in a red, one wave is in a red, and another wave in a blue, and both are moving towards each other. So blue is moving towards the red. So what happened when these waves will combine? We call this phenomena as interference. And how we'll find the resultant wave? So when two waves meet, the total displacement at any point is equal to the sum of displacement of individual wave. Example, when these two waves combine with each other, so the combination of these two waves will result or produce another type of wave. So this one is a red, and then the blue one. So when they meet, example, the height of the red was 4 centimeter and the height of the blue was 2 centimeter. But when they combine with each other, as a result, what will happen? Because 2 centimeter and 4 centimeter, so the resultant wave will not see two waves. What we will see a resultant wave with a higher amplitude, and this is called superposition of the waves. So when two or more waves combine with each other, they give rise to another wave, and we call that as superposition. And if they increase the effect of each other, you can see here both waves are increasing the effect of each other. Whenever two waves increase the effect of each other, what we call that as constructive interference. Why constructive interference? Because both increase the effect of each other. So example, if these are the sound waves, then you will hear a loud sound. If these are the light waves, then you will see or observe a bright light. Then another type of interference is called destructive interference, in which two waves try to cancel out the effect of each other. So example, if this is 1 centimeter, so in this case, what will happen when the two waves will combine? The red one is the first wave and the blue one is the next. But when they combine, the crests join with the trough, so they try to cancel out the effect of each other. As the two waves try to cancel out the effect of each other, so as a result, if the height, this was 4 centimeter and this depth is 1. So the resultant wave, the yellow one, is a resultant wave which is having a lower or smaller amplitude as compared to. So we call this type of interference as a destructive interference. Why destructive? Because both waves try to cancel out the effect of each other. And where you observe this constructive and destructive interference, this constructive and destructive interference, like example, if in an assembly, if in a school assembly, if everyone is saying the same word, or reading a national anthem or saying a national anthem, so because everyone is saying the same word, so as a result, what you will observe a louder sound because of constructive interference. But another example, if everyone is saying a different thing, so as a result, their voice cancel out each other, and you will observe either a no sound or a low sound. So this is an example of interference or superposition, that when two or more waves combine with each other, they may give rise to constructive or destructive interference. Is it clear? Any doubt in this, the interference? Then interference, part difference and interference. Part difference, example, if we have two waves which are coherent. What is the term coherent means? Coherent means that the same phase is coming out. Like example, if the first wave crest is coming out, the second wave also crest should come out. If two waves having a same phase, like the first crest is coming out, then the other source also crest is coming out, we call that as a coherent. Same phase is coming out. So what is the part difference and interference? Example, you have coherent sources. So one wave, two waves, three waves, and 3.5 waves travel there. 1, 2, 3, 4, and 4.5 travel there. So how many waves travel there? 4.5 wavelength or 4.5 lambda. How many waves travel from S1 to P? 3.5 wavelengths or 3.5 lambda. What is the part difference? Part difference means difference in the wavelengths. Difference between the wavelengths, like here 3.5 wavelengths travel, here 4.5 wavelength travel. So what is the part difference here in this example? So the part difference is equals to 1 lambda, because 4.5 minus 3.5 is equals to 1 lambda. So whenever the part difference is lambda or 2 lambda, 1 lambda, 2 lambda, 3 lambda, and so on, whole number, then what type of interference will occur? Constructive interference will occur, that two waves will always increase the effect of each other. But if the part difference is half lambda or 1.5 lambda, 2.5, like example 1, 2, 3 waves travel there. And for the other one, 1, 2, 3, and then 3.5. So here this one is 3.5 wavelengths and the other one is 2.5 wavelength. So what is the part difference when I take the difference? So 3.5 minus 2.5, sorry, 1, 2, 3, 3.5. 1, 2, and 3 wavelengths are there. For this one, it's 3 wavelengths. So one side 3.5. So when you take a difference, 3.5 minus 3 means 0.5 wavelength. So whenever, if it's half wavelength, 1.5, 2.5, what kind of interference will occur? The condition, it will have a destructive interference. Destructive interference means two waves will cancel out the effect of each other. Or we can also say maxima and minima. So here in this example, if you have only when it is half, like 0. If it is 0.5 wavelength, if it's 1.5 wavelength, 2.5 wavelength, 3.5. When it is like this, then it will be destructive interference. When it is full wavelength part difference, then it is constructive interference. So what we'll observe, example, if I say you have source 1 and source 2, and there is a screen. There's a screen. So on this screen, what you will observe, if these two are the light waves, you will observe a maxima. Maxima means constructive interference, and then you will observe minima, destructive interference. Then again you will observe maxima, constructive interference, minima, destructive, and so on. Minima, then maxima. What is the reason why there is a minima and maxima there? Because what happened? When the wave travel from source 1 to P and source 2 to P. So what happened if they have the path difference whole number, like 1 wavelength, 2 wavelength, 3 wavelength, 1 wavelength, 2 wavelength, 3 wavelength. So what is the path difference here? When the central maxima, the path difference is 0. So if the path difference is 0, what type of interference we'll observe? We'll observe a constructive interference. But if it is not exactly at the center or above the center, either up or down, so what will happen? 1 wavelength, 2 wavelengths, 3. But here 1, 2, 3, 4 and 4.5. So one is 4.5 wavelength, another one is 3 wavelength. So what is the path difference here? The path difference is 1.5. So whenever any point the path difference is 1.5, so what we'll observe? We'll observe minima. So in this case, we'll observe maxima, minima, then minima, and it will continue so on, which shows that the variation of the path difference, that one side, if the path difference is a whole number, it will have a constructive interference. If another side there is a destructive interference, when a path difference is half lambda, 1.5, 2.5, 3.5. Is it clear? So follow the 3 steps. What you will do, you will calculate or measure the path difference, calculate the value of half wavelength, and if the path difference is even number multiplied by lambda, then it is constructive. Odd number multiplied by lambda by 2, then it is destructive. So example, this is just an example. In a ripple tank, 2 dippers are there. These are the dippers, S1 and S2. So this is source 1 and this one is source 2. Vibrate exactly the same way, producing a coherent wave. Coherent means every time if crest is coming out from one, the crest is coming out from the other one. And water waves having a wavelength of 2 centimeters. So wavelength of water which, or the wavelength of a wave which we are using is 2 centimeters. Their distance from the dippers are shown. Sorry. Then what we have to do, we have to find in the question, tell if the constructive or destructive interference take place at X and Y. So first what we will do, we should know a distance from S1 to X. How we can find a difference from S1 to X? If this is 6 centimeter, if this is 6 centimeter, and this one is 7 centimeters, so we can use the Pythagoras theorem to find a distance between S1 and X. 6 square plus 7 square take a square root. So 6 square plus 7 square, and you take a square root, so you will get this distance, because hypotenuse square is equals to base square plus perpendicular, or it will be square root of 6 plus square root of 7. So 6 square 36, 7 square is 49, 36 plus 49, 115. What is the square root of 115? What is the square root of 115? 115. Square root of 115. Yeah, square root of 115, that's 10.7. So if this distance is 10.7, and for S1, S2 also, it will be 10.7. So 10.7 on, so what is the part difference if both distances are same? The difference is 0. 10.7. So 10.7 minus 10.7. So what we will get? We will get 0. So if the part difference is 0, it means what kind of interference will occur? It will have a constructive interference. So at point X, there is a constructive. What about Y? For S1 to this is 16. That is already known. But how you'll find this distance from S2 to Y? So how you'll find this distance? Again, you will use the Pythagoras theorem. This one is 16 and this is 12 because 6 plus 6. So square root of 16, 16 is square plus 12 is square in a square root. So what you will get this distance. What is the answer? 16 square plus 16 square is how much? I think 216. $256, 16 square. And 12 square is 144. So that's equal to 400. And when you take a square root of 400, you will get 20. So this distance is equal to 20. Now when you check the part difference from source to the distance point Y 16, source to distance point Y 20. So 20 minus 16, if 20 minus 16, that's equal to 4. But how many wavelengths? Because one wavelength is 2 centimeter. So 4 centimeter, how many wavelength? So 4 cent length divided by wavelength, you will get number of waves. So the part difference is equals to 2 wavelengths. So it will be constructive. Is it clear how we can identify? So simply we identify the part difference, and using a part difference we identify whether it is constructive or destructive. Then standing wave. What is a standing wave? When two waves, why we divide it by 2? Because the difference, look here, this was 16 and this is 20. So when I calculate the part difference was 20 minus 16, which is equals to 4. But that is the length. I need how many wavelength in terms of wavelength? So one wavelength one wave was having a length of 2 centimeter. So 4 centimeter, how many waves will be there? X. Cross multiply, so you will know the number of the wavelengths. Because one wavelength is 2 centimeter, that's given in the question. So 4 centimeter will have X wavelength. So 4 centimeter, how many wavelengths are there? 2 wavelengths. So whenever part difference is lambda, 2 lambda, 3 lambda, and so on, then it will be a constructive interference. Is it clear? Then what is a standing wave? Standing wave is also a interference, but in case of standing wave, when two waves are traveling in opposite direction, they give rise to a standing wave. Like interference of the two waves, because interference can occur both way. Like if you have a source 1 and source 2. Source 1 wave are traveling like this, source 2 wave are traveling like this. So they can combine, and where they will combine we call interference. But what is a standing or a stationary wave? So the condition for producing a standing or a stationary wave, when two waves, two same type of wave traveling in opposite direction of each other. So what they will give rise to a standing wave. So means they will give a, like this is very common. If you take a rubber band and you fix this rubber band from both ends, and you disturb this rubber band, so what you will observe? You will observe it will vibrate like this. So what is this? Basically, this is a standing wave. Why it is a standing wave? Because what happened when you disturb the rubber bands, it produces two waves which are traveling in opposite direction. So when two waves travel in opposite direction, they combine, and we don't see the two waves, we see a resultant wave, and that resultant wave is simply known as the standing wave. So to produce a standing wave, the condition is that waves should travel in opposite direction. So this is also an interference, but the condition that waves must travel in opposite direction to produce a standing wave. Like if two waves are traveling in the same direction, they cannot produce a standing wave. And when a standing wave is produced, as a result, what we see nodes and antinodes. Example, the point where the two waves cancel out the effect of each other, we call that as a node. The point where the two waves, zero amplitude or cancel out the effect of each other, we call that as a node. And the point where they have the maximum amplitude, we call that as antinode. Same thing, the point where they cancel out each other, we call node. And where they increase the effect of each other, we call antinode. So nodes and antinodes are only formed when two waves traveling in opposite direction. So as a result, it might produce a standing wave, the wave which will not change its position. So waves will not change their position. The point where they cancel out each other, the two waves cancel out the effect of each other, we call that as a node. The point where they increase the effect of each other, we call that as antinode. Is it clear? The nodes and antinodes. It's like the points, the region where the two waves, two continuous waves which are traveling in opposite direction. The point where they cancel out the effect of each other, we call that as a node. And the point where they increase the effect of each other, we call that as antinode. So nodes and antinodes are formed whenever there is a standing wave. Like example, a very common example, if there is a well which is filled with water, and you say something, you're at the top of this well and you say something. So what happened? Your sound waves travel towards the water, and your sound waves, when it hit, it bounce back. So basically there are two waves, number one which is going and number two which is coming back. So the one which is going and the one which is coming back may combine with each other. So if they increase, like if you receive an antinote, you will hear a loud sound. If you receive a node at the point where you're, if you receive a point or this point, if you receive no sound or low sound, then we call that as node is formed. Is it clear, the idea node and antinode? So you can see here, these are the points. Node means where they increase the effect of each other. Antinode means where they decrease the effect of each other. And the formula, the relation between the length of a wire and the wavelength, this is a formula which you have to learn or memorize. That length of the wire is equals to n multiplied by lambda by 2. And what is n? N is the number of the loops. Like how many loops are there? In this example, how many loops are there? 3 loops. So this is one loop, this is second loop, and this one is third loop. So it is vibrating in 3 loops. So value of n will be 3. 3 multiply. So whenever, like example, if I say, what is the distance between the node, distance between the two successive nodes is lambda by 2. Okay. Why? Because when you have, this is one complete wave. So one complete wave will have node, node, and node. Like 3 nodes will be there, that's equal to one complete wavelength. When 2 nodes are there, the distance between 2 nodes is equals to lambda by 2. And distance between node and antinode, node and antinode is equals to lambda by 4. So the formula which relate the total length of a string with wavelength L is equals to n, where n is a number of the loop. In this example, there are 3 loops. Wavelength or lambda divided by 2. That's a formula. So when it is vibrating in one loop, the value of n is equals to 1. When it is vibrating in 2 loops, the value of n is equals to 2. When it is vibrating in 3 loops, the value of n is equals to 3. Is it clear? Then diffraction, how we define a diffraction? Diffraction means the spreading of the wave around the edges. When the gap is much larger, the gap size, this gap size is much larger than the wavelength, then a small amount of diffraction. when gap size, so wave after passing a gap, how the width of a gap influence. So when the gap size is approximately equal to the wavelength, that time maximum diffraction. Here also diffraction occur, but small amount. So for maximum diffraction to occur, the wavelength must balance with the wavelength must balance with the gap size. If both are equal, then maximum diffraction. If it's more or less, then the diffraction will decrease. If it is too small, then there is no diffraction. So the idea of a diffraction is a spreading of the wave around an obstacle or near the edge. We call that as diffraction. And the last property is a polarization. What is the term polarization means? Basically what happened? What is the term polarization means? Look, when a light is produced, if you have a light source, example your lamp or a bulb, so when it is producing a light is transverse wave in which the particle vibrate or vibration of the field is perpendicular to direction of wave. So some of the particle vibrate vertically, some vibrate horizontally, and some of them making certain angle. So when they produce the light, when the light is coming out from this, this light will have all the component. So when this light is having all the component, what we call this light? We call this light as unpolarized light. So light which is having all the components is known as the unpolarized light. But what happens if this light, when we pass through the filter, there is or a glass. So when we pass this light through a filter or a glass, it only allow one component to pass. So when it only allow one component to pass, the light which is having only one component to pass, that light is called polarized light. And this is unpolarized light. But using your eye, how you can identify it's a polarized or unpolarized light? Because unpolarized light will have high intensity and polarized light will have low intensity. So when we pass a light, unpolarized light, through any filter, which we call filter or polarizer, the polarizer will stop most of this component and only allow one component to pass. So that kind of light is called a polarized light. Where you can observe this phenomena, you can observe this phenomena in a sunglasses. Like example, the light which is coming from the sun, the light which is coming from the sun is unpolarized light because it is having many component of vibration. But if you are using a sunglasses, so if you are using the sunglasses, these sunglasses will only allow one component of a light to pass. So when you receive this light, this light will have only one component. So when it passes through, it will have only one component. And as it will have only one component, so what you will observe, Only one component will pass through the glass and you will observe only one component. That's why it will appear to be dim, or the light will become dim as what was coming from the sun. So sunglasses also use a polarizing filter, so they absorb all the component and only allow one component to pass. Is it clear? Any doubt in this? The concept of polarization? And polarization is only for transverse wave. The longitudinal wave cannot be polarized. So sound waves can reflect, they can refract, they can diffract, but they cannot be polarized. Polarization, because for polarization to occur, the direction of the wave should be perpendicular to direction of vibration. But in sound waves, which are longitudinal, the vibration is not perpendicular. Then this is the electromagnetic part, the electromagnetic spectrum. It's the same thing what you learn in O levels. You have to learn the order. Radio waves, microwaves, infrared, visible, ultraviolet, X-ray, and gamma rays. So radio, micro, infra, visible, ultraviolet, X-rays, and gamma rays. These are the rays which we use. And you have to learn the, like gamma is having the highest frequency, highest energy, where radio is having the longest wavelength and shorter frequency. For each type of wave, radio waves where we use for radio and TV transmission, microwaves we use in mobile or satellites, infrared we use in temperature detector, visible we use like to observe, ultraviolet light for fluorescence or to glow something, X-ray for scanning the luggage or suitcase or human body, and gamma rays are used to sterilize or used for radiotherapy or treatment of the cancer. And you have to know that the wavelength of a violet is 400 nanometer and wavelength of red is 700 nanometer. Green is about 500 and orange and yellow about 600. It's better you learn these range as well. Nanometer. So it's the same thing. You have to learn or memorize this. Okay, we'll start the last part, which is about the light.